Okay, so what are we going to talk about tonight? Metaprogramming in JavaScript and Ruby, mostly using JavaScript's Proxy Object, which is relatively new, and Ruby's method missing, which is ancient and heavily relied upon and maligned. All right, so first up, metaprogramming. Well, what's meta? Meta is self-referential. It is referring to itself. Thus, metaprogramming is programming that references itself, programming about programming. That is, you treat programs as the inputs to programs. Programs are data to be processed. So an example of metaprogramming would be essentially macros. So if you used M4, if you use C preprocessor, that would be a form of metaprogramming. Other forms of metaprogramming would be adding DSLs to your software, adding DSLs in other places, embedding Ruby, JavaScript, Perl, whatever you want, Tickle into another program. You can engage in it that way. Essentially, metaprogramming oftentimes is code that makes code or code that acts like code that the language would provide. So it oftentimes adds language as features. Metaprogramming is a pretty generic term, but generally it refers to programming about programming. And just to hammer it home, I'm going to quote Mark Bennett. Mark said on Slack, code is data, data is code. All right, thank you, Mark. So what are we going to do today? We're going to talk about methods to allow objects in JavaScript and Ruby to handle complex message calls or method calls to them that might not be defined ahead of time. We're going to learn about the proxy class in JavaScript. And we're going to learn about method missing in Ruby. Before I get there, feel free to ask questions anytime. And I can always check the chat. So like DSL as in domain-specific language. Yeah, so definitely domain-specific languages. A lot of them, you embed them, or a lot of them are just additions to existing languages. All right. So let's verify. Good. Okay. So we're going to go over a couple of concepts to talk about. First up, object. An object is pretty similar in both Ruby and JavaScript. Its fundamental purpose is to represent something. It's your kind of first line of abstraction. An object typically has attributes or properties. It can handle method calls or messages sent to it. It often inherits methods from a class. Objects know about themselves. They have an identity. Objects know that they're not another object. They also have their own state, typically. Sometimes an object just exists because its identity alone is important enough. But fundamentally, we use objects as our first line of abstraction. Objects in Ruby and JavaScript differ. JavaScript objects are basically a hash, and Ruby objects are basically two namespaces of instance variables and methods. So they can be quite different, but fundamentally, at the end of the day, they're kind of the same thing. Now, I mentioned that they often inherit methods from a class. In JavaScript, you really don't need a class. You can just be an object. In Ruby, typically you engage with classes. The class is the structure. This is the platonic ideal of what your object is going to be. Okay? Classes create objects. And the objects that classes create are instances. These are objects made from a class. Also, just an individual object lying around would be an instance as well. Okay, and just want to check again. Cool. All right, so typically objects keep state, and they usually keep state locally to the object itself as either attributes, properties, instance variables, whatever you want to call them. They all have different names in different programming languages. Private members, local members, all sorts of different names. But it's basically a value or a variable associated with that object encapsulated by the object. Some languages hide these properties. Some languages expose them publicly. So it depends which language you're in. Then there's methods. Methods are code bound to an object. In some languages, a method is just a property that is a function. In others, a method is a special kind of function. Sometimes their namespace is shared with the properties. Sometimes it's not. Depends which language you're in. For JavaScript, basically anything goes. It's all public. For Ruby, it's kind of like two namespaces. Now, that's just the method, and that's just code attached to your object, and it could come from the class. Typically, when you call a method on a object, it's called a method call or a message. In Smalltalk, it was never just supposed to be direct code. It was an actual symbol that was sent to the object, and the object was supposed to receive the symbol and decide what it was supposed to do. In something like C++, it's totally just dereferencing a pointer and calling something, or going up the tree of which classes you're related to and then calling something. End of the day, does it really matter what the difference between method call or message is? Fundamentally, a message means I want an object to do something. So a message would be a higher level abstraction. I'm going to use them interchangeably and inconsistently nonetheless. Related to that, we can have a delegate. A delegate is an object that your object has, so it aggregates or composes it, and your object will often defer or send operations to that delegate. It will delegate responsibility to that object, and that object is typically stored within the holding object as a attribute, property, or instance variable. Okay, and just want to make sure, no, we're all cool. All right. Now, delegates are important because we oftentimes use delegates to proxy, to decorate, to wrap, to adapt. This is all programmer slang for receiving messages, doing a little more work, passing the message off to something else for the rest of the responsibility, and that something else might be a function or a method or something like that. You might have heard of these as like before methods, after methods, filters, pipe and filter architectures, that kind of stuff. You might have made decorators as instances which actually execute these operations, adapters, wrappers, facades. These are all objects that do this stuff, okay? And these are common kind of behavioral patterns that we follow in OO languages. Next up, that's important to this talk, is reflection. Reflection is about allowing an object system to ask questions about the objects it has. So objects typically know their identity. Their identity is known to them. They can access that. But other aspects they might not have runtime access to. So with reflection, typical things that you ask of an object under reflection are, what class are you representing? What class were you created from? Do you have a constructor? Can I get a new instance of you? What properties, attributes do you have? What methods do you have? And these reflection mechanisms are very varied depending on which language you use. But nonetheless, these are really valuable to metaprogramming, because in metaprogramming, sometimes the client classes that you're working with, you have no clue about them and you have to programmatically explore them. And that's why reflection is useful, because it's usually an API that allows you access to that kind of information and allows you knowledge about the system. In dynamic programming languages like Ruby and Smalltalk, you can change the entire object system on the fly. You can change how things are parsed, how things are read, and it can be really nuts and totally unsustainable, but fun nonetheless. All right, so does anyone have any clarification questions about any of that stuff? All right, I think we're good. Okay, so we got all that down. I talked about objects and classes, instances, methods, properties, reflection, all that kind of fun stuff. So let's get into it. Let's start off with a proxy. We'll start in JavaScript world. JavaScript typically hasn't. JavaScript is a really flexible and interesting kind of language. It is based upon ideas from the self language, which are based on ideas of prototyping. So this meant that by default, you already had methods or ways of exploring the objects themselves. You can ask what keys they have. You can ask them for their prototype, and then you can explore their prototype. So that was really interesting, but it wasn't necessarily enough. So what later versions of JavaScript and ECMAScript came out with was reflect and proxy. Reflect and proxy do operations that you might not have had access to in JavaScript itself, and they do them for you in order to do things like receive messages and delegate messages, call methods on objects in expected ways, implement the in operator, and stuff like that. If you want good documentation of proxy, probably the best that I found is the, it's confusing. It's the MDN website, and they do an okay job. They don't cover everything that the handler does. They do cover a bunch, and they cover a bunch of side things. So I do recommend looking at it. It is pretty well supported by everything other than Internet Explorer, so it is relatively mature. Yeah. Okay. But if you want to actually figure out how proxy works, you're going to have to go to the ECMAScript spec, and you're going to have to deal with the fact that it's kind of all over the place. They don't give they don't give you really good details about things. They're really talking to language designers about the actual operations that need to occur. You can derive what you want from there, but it's not super fun. I'll just say that. Now, I'm mostly going to talk about proxy, but reflect, which I don't cover very much or at all, is also covered in the spec. And reflect lets you call methods on functions, call their prototypes, ask a bunch of information about objects. Reflect is pretty powerful. Proxy, its purpose is to wrap or decorate another object and intercept calls to it. You can intercept property accesses. You can intercept property gets, sets, deletions, definitions. You can even intercept changes in prototype, setting prototype. You can override has. Probably that's the coolest thing you can do with proxy, is overriding has really easily. And frankly, proxy came late. It's relatively new, but it came late to JavaScript because it was already kind of prototype driven, which I've covered. All right. So we're going to talk about the proxy. I'm just going to check to see if that led to anything. So eval random code is pretty well meta in this context. So eval is dangerous, powerful, very useful, very meta, does its job. Respect eval. And eval was invented very, very early. So it was one of the earliest things implemented in common, or not in common Lisp, in Lisp. And pretty sure it existed before like 62. Wasn't too hard for them to write it. So that's kind of cool. All right. So I'd mentioned that proxy handles things like gets and sets. These are all the things, all the methods that will be looked for in your handler. If your handler has any of these methods, a handler you pass to the proxy object will call these things on your handler. So if you have a get, it'll do get. If you got a has, it'll do has, set, delete property define, get prototype of, is extensible, prevent extensions, stuff like that. So we're going to explore get because it's the easiest. So we're going to intercept the access of properties in JavaScript of objects. We first need a function to access, to handle the access, which we'll call handler get. This will deal with a target, so usually the object being changed, the property being changed, and the receiver. The receiver is typically what this was set to when the get was called. So the object being changed is not this, it will be target. Your old this will be receiver, and the key, the property name, will be property. And this might be a symbol and not a string. Sometimes it is a string. It kind of depends what you're doing. So we're going to do a get. So let's just start. Let's just start with an object that we're going to wrap. So var obj, and this is just a basic object, just pretty plain Jane object. Its class is object. Okay, and it's empty. First off, we're going to make a proxied object. We're going to wrap our object with proxy, and we're going to use this handler. Okay, so make handler makes an object. Really, you could have just passed in a new class. So you could have gone new get handler, right? And you could have just done it like that, where get would be a defined method. So we've got a get, it says handler get. So let's go read handler get. Handler get takes in your target. This is going to be the object being modified or being get on. And this is the property being got. And this is the this. When this runs, what will happen is we'll see if property is already in target. So is the property already in target? Does it have it? So it really calls the has handler. And if it is, just return it. Otherwise, return this silly string that says it's not defined because we didn't want an undefined or anything like that. So this is just purely for the purposes of explanation, okay? So the proxy object will wrap this object, and what we'll do is we'll run a set on it. We'll set the fruit property to durian, the best fruit of all time, and then we will console log that, and then we will try console logging something that doesn't exist, such as salad, okay? And we'll see what the result is, and then we'll go back and we'll console log object salad, the thing that was wrapped, to see if it's different than the proxy objects. So in your head right now, think about what this thing will actually print out. So what will this print out? Probably that. What will this print out? Maybe that. What will this print out? Okay, so you got those 3 print lines in your head. All right, let's just eval this. This is org mode, so I can change things as I want. All right, cool. So we got prop salad not found, we got durian, and we got undefined. So being a proxy object, it wasn't modifying the original object in this case. It was only just intercepting calls and returning a value. I could change that value right now. So I could change it to be, I don't know, just change it to be false and run it again. And you see it becomes false. And the object that was proxied is unchanged, right? So let me just go back, see if there's an issue. Yeah, so if you use a mock library, a lot of the time they'll do stuff like this. They will basically decorate and wrap stuff and intercept calls and count calls and check if state changed. A lot of your mocking libraries do all this really fun stuff. And they do a lot of it with reflection, especially if it's in like Java or something like that. Yeah, exactly. Okay. Now, kind of silly to return a string or a false. So, let's change that default value. So let's do the same thing. We'll change the default value to false just by adding this parameter, and we'll just capture it in this closure, right? And we just got the default value. Okay. So we're going to do exactly the same thing, except we simplified it down a little bit. We've just set the method, the get method handler right there, and it works. Okay. Now, if I didn't set the get method, if I called it, I don't know, xget, I can run this again, and you can see that what happens. So I run it again, and now this is undefined. So what happens is if you don't override the handle, the get or the set, it's just going to do the default behavior. It's just going to fall through and do the default behavior. So if I return it back to get normal and I run it again, we'll see that it does indeed intercept the call to po.salad, and it returns the default value. So I can change the default value here to anything I want. I could change it to rambutan. It'd probably work. I bought one of those in Edmonton. Surprised I could buy it here. All right, so it did work. So you can change the behavior at runtime. And the cool thing about the proxy is that it's not the original object. It is truly adapting or decorating that object itself. So that's kind of neat. Okay. So that's fun. So let's just summarize proxy. You can use proxy in JavaScript to decorate other objects in order to intercept calls. You need to wrap those objects with proxy for it to work. So that's kind of annoying, which means that if you make a new version, you make a new instance of that object, you still need to wrap it with proxy for that to work, which means that you pretty well have to make something that either wraps up the constructor or is a build method or something like that. So the proxy object's pretty awkward in JavaScript, but you can get around a lot of it just with the prototype system alone. Okay, so you can A lot of the stuff you maybe would think Proxy would work well for, your prototypes will probably handle it good enough. All right. So if you got any questions, write them in the chat. I'll definitely answer them. Whenever you see my screen go star like this, I'm here looking for questions. All right, let's get on the Ruby side of things. Now, I'll just say this. I dabble in many languages, and I'm pretty well the master of none. So if I do anything silly in Ruby, I would like to be corrected. I'd like to know how to do it better. I tried pretty well on this, but whatever.
So, as someone who uses Ruby a lot, Abram, I would state that Ruby is silly by nature, so don't worry.
Thank you, Andy. All right. So Ruby, probably the biggest metaprogramming thing you run into with Ruby is probably method missing. There's other stuff. You can use object, you can use module. There's a lot of reflection stuff you can do in Ruby, but method missing is kind of this black magic that everyone likes to use. Like it's a popular black magic in Ruby. So it's kind of interesting. People use it to make things on the fly. People use it to respond to things on the fly. It's kind of crazy. And it's really easy to use, which I think is why it's so popular. Essentially, when you call a method, if the method does not exist in the current objects class or any of its superclasses, then the method missing is called on the immediately again. So it's like your object, so you go obj.method call. If that call's not there, it's going to go obj.method missing. It's going to jam your original method name in there as a symbol. It's going to plunk in your method arguments. And if you had a block, because Ruby allows code to be thrown around randomly as blocks, which is kind of neat, it'll be there. So if it ends in a block, it'll be there. And you just need to say what you want to do. What you return here will be returned. So if you are meant to delegate and return something, you should have this value be something that you're returning. Just be aware of that. Okay, so you just put this method anywhere in any class, and bada bing, it now responds to methods that aren't defined in that class itself. You can put this in your interpreter too, and then things can get really crazy. So have fun with that. People like adding bear words to Ruby using this method. They do it mostly to show off. Very few people do it very seriously, but you can do it. And I think that's really one of the really nice aspects of Ruby is the ability to like change everything really quickly, show off really cool ideas, and then don't use them in production code because it's really dangerous unless you're Rails. And then, yeah, you kind of agreed to do that. Okay, so let's look at an example in Ruby of an example class that can respond to missing methods. Okay, so let's start off with a very simple class. Here's example. We've got our constructor, does nothing. We got our method missing. It takes in the method name, the arguments, and a block. And all I'm going to do is I'm going to assign an instance variable that I can query later if I want for this object. And it's just going to be a list. The list is going to contain the symbol method missing, so I know where it came from, the method you are calling, the arguments, and the block. So here we make a new example method. We call the eat method, and we're going to eat pi. Well, it's a string, so it's not actually pi. And then we're also going to fool around, and we're going to make a block with one argument and one block, okay? And then at the end here, I am just returning a dictionary, or I don't know what Ruby calls them, a dictionary that has one key for LC1 and one key for LC2, and we get to look at the return values of both of these. So, that's not what I want to do. Going to evaluate this. It evaluated. I can show you that it's actually running it. Boom, there, it ran it. Okay. So method missing, eat pi nil. So no block, so that's nil. Notice how the method eat, which is right here, that method turned into a symbol, which is understandable. Ruby doesn't like using strings for everything, which is the right way to do things. That's fine. And then we can see the arguments. That's cool. And we got nil. Next up is LC2. And I'll just redraw this such that it's easier. LC2 is method missing, so that came from there. It said block because I used the word block because it was unoriginal to do so. And then arg1, and we can see that symbol showed up. And then this function, well, this block showed up, this procedure, and it was defined and created, and it's right there. Okay, so this identity procedure block is available, and we can pass it along if we want to. Okay, so method missing, intercept any kind of call you want, and you can even do it with blocks and stuff. You can do it with variable arguments, you get the method. So easy peasy. Let me just see if there's any questions. Hash. Okay, so it is a hash. All right. Let me see where it's superclasses. Yeah, you got to watch out with the O stuff because every dot operator is really quite dangerous. Just as a reminder to everyone, the dot operator is the most powerful tiny bits of little pixels that you use in O languages. The dot operator for method dispatch is pretty crazy. So what the dot operator does is it says, hey, object, do you have that method? Object goes, let me check. If this is a class-based language, it'll go, hey, my class, do I have that method? And then its class will say either yes, here it is. So now call this method with this or self set to you object. And then we'll also pass in the parameters. If it's not in that class, then the dot operator has to go and interrogate the class and say, who's your superclass? And the class is like, oh, my superclass is this other one over here. So the dot operator walks over and talks to that one and says, hey, do you have this method? And then that superclass is like, no, I'm part of like a dependency injection framework. That's way higher up. Anyways, 5 superclasses later, it hits the top superclass and then it says, hey, do you have this method? If that one says yes, then it returns that method. You pass in your object. You're all good to go. This and that and self are all set. If it's not there, then something like method missing will be called again all the way back down to the original object, and it will follow that same method chain. Okay. So just remember that stuff. Okay. So Ruby's pretty flexible for that stuff. Let's start with a really poor example with dogs and cats. So in this one, what I'm going to do is, if you haven't seen this, this is your first reflection attempt. I'm telling object to remove the constant dog, which means if dog was already defined as a class, just garbage collect it. It doesn't exist anymore because I want to completely redefine this thing. Okay, that one's pretty fun. Next up, we're going to talk about the dog class. The dog class has a basic constructor. It has a speak, and it has legs. So it'll return rough or return 4. Pretty basic. So I'll just evaluate this. And the class, defining a class returns a symbol of its last method. Weird. Do the same for cat. We'll remove any cats, and then we'll make a initialization. And I'm a really lazy programmer, so I think dog already has all the stuff I need, you know? But you know what? Dogs and cats aren't the same. So I don't think cat should inherit from dog, right? I don't think it should inherit at all from dog. So what I'm going to do is I'm going to treat dog as a delegate. I'm going to use the implementation of dog because it has great code that I need to use. But I'm not going to be a dog. I'm a cat. And we all know that cats are way above being a dog. So we can't have them in the same inheritance hierarchy. We know that cat is a dog is a false statement, and dog is a cat is a false statement as well. But a cat who has a dog and then uses the dog for the rest of its work in a lazy kind of manner, well, that sounds pretty cat-like to me. So what we're going to do is, instead of re-implementing all that dog stuff, is we're going to engage in method missing. And we're just going to say, if the method that we're calling is not defined on cat, then call it on our delegate. In this case, it's a dog. If I allowed it as a parameter there, it would be dependency injection. So what does it do? It takes the method, the arguments in the block, and it calls the method on the delegate. But you'll notice that I didn't go delegate.m or something like that. I used .send. This is message passing. I am sending a message to the delegate, and the message to the delegate is, hey, I'm sending the message M to you, and here are the arguments. So this is actual message passing. That's cool. We're getting in the small talk realm now. All right, what happens? Well, it just defines the class. It's not doing much. So what we're going to do is we're going to make a new cat. We're going to make a new cat, and we're going to call speak on cat. Notice how speak is not defined here. I want you to think about what string is returned or not returned when cat.speak is called. So think about, what is cat.speak going to return? Okay, because if you don't think about it, this is just a magical demo, and I'm just saying magic words, and it's all magic. You got to think about what the actual return value is. I just evaluated it, and it's rough. I think that would be offensive to most cats, so maybe we can just address that. I'll just open up the cat class again, and I'll define speak inside of it. I'll make a new cat, and we'll run speak and legs. So what do you think the first value of this list is going to be, and what do you think the last value of this list is going to be? Okay. Going to evaluate. Can you guess? And it's meow 4. Okay. Now is a good time for me to go look if there's questions. All right. There's no questions. Good. So what happened here? Well, I opened up the cat class for extension. I defined the speak method on the cat class. So when .speak was called, it didn't call method missing because it was defined, so it called it. But when .legs was called, method missing did indeed run, and it called legs on the delegate. Okay, this is a really inefficient way to do your implementation inheritance, but it does work, so you can do it. I think the delegate example is kind of bad. I think I'm pretty sure there's Ruby gems that delegate for you. I know that C# does delegate off the bat for you. So it's kind of a common idea in a lot of O languages. And I'm pretty sure Ruby has better ways to do it. I'm just giving you an example of using method missing. Okay, so what happens when I try to do something that's not in the dawg? So I go cat, new cat, and then I ask the cat to consume the sun, which is kind of a tall order. What do we get? We get an exception. No method error. Undefined method consume the sun for dawg. Notice how it's not for cat. It's for dawg because it went and looked for it in the delegate. Okay. Let me just check on questions. We're all good. Okay. So let's go deeper into some examples. I've covered method missing. I've covered JavaScript proxy. So let's talk about auto Vivify. Now, if any of y'all are, sorry?
Do you want to share your screen?
Oh, good point.
Yeah, you can go back to it. Okay, sorry.
All right, so here's cat consume the sun. So I'm going to run it, and it says consume the sun is not defined for dawg because dawg was delegate. Okay, so we're going to go through some examples, and I programmed a lot of Perl. I was a pretty good Perl programmer. I understood a lot of the guts of Perl, got pretty deep in Perl. And one interesting feature with Perl was auto Vivify. Auto Vivify means to auto enliven something, make it live. So essentially, you could make something exist just by checking on it, which seemed a little bit bad, or by assigning deep into it. So what Perl would do is they would allow you to assign really deep dictionary references or hash references, and you could go like 4 hashes deep with keys, and it would make the hashes all the way along. In Python, you might use default dict. In JavaScript, it's a little bit awkward. So let's look at auto Vivify for JavaScript. So we're going to start, and what we want to do is when something is called that doesn't exist, we want it to persist. we want to assign it a default value. Okay, so by accessing it, it exists now with a default value. This could be important because you might want everything to be a value, like a number or another object, something along those lines. So we've got ourselves our make handler. And inside of our make handler, we override get. And then the get, it takes the target, the property, and the receiver. We check to see if the property is in the target. If it's not in the target, then we set the target property to the default value. Okay. Otherwise, and after, we just return it. Okay, so that's nice. We could also just call reflect. No, that didn't work. Where was I? We could also just call reflect and work on the arguments themselves, since they would be the same, and it would just be target, prop, and receive. So this is just going to return the thing, and it's going to set it to a default value. So for fruit, we're going to ask for fruit, and it's going to return the durian. For salad, it's going to set a default value. And then I'm going to show you that that value persisted throughout the object itself, not just, so there's the original object and the proxy object. So by setting the by querying the proxy object, it exists. Okay. But maybe I want to show you this, where we'll ask for salad from the object first, then the proxy object, then the object again. Okay, so let's run it. So we start off with fruit. We got durian. Object salad is undefined. We queried the proxy object for the salad, and it was false. And object salad is now false because this code ran this code, so now it exists. It's auto-vivified. Okay. Super exciting. Let me just check. Good. All right, let's talk about auto-vivify in Ruby. It gets a little bit more complicated because Ruby's instance variables are not really exposed unless they're like getters or setters. So it's a little different. So let's make a class called Viva. And Viva will have a default value that you initialize with. And what we're going to do is, let's just look at method missing. I think it's clearest. Look at method missing, and it says that I want to convert the symbol of the method to a string. And then if the end of that method has an equal sign, then that means that it's actually a setter. So let's look at the code here. So we got V, and I go Viva new, and I say I want everything that's vivified to be a symbol called undefined. And then I will call v.c equals x. And what this actually does is it calls the method v.c equals. Okay, so that's cool. So what I have to do here is I have to see if the last character is an equal sign. Okay. And from what I read up on Ruby identifiers, the equal sign can only occur once in the identifier and only at the end. Interestingly enough, a bunch of the other crazy Unicode characters are perfectly A-OK to use as identifiers and within identifiers. So you could use a weird Unicode equal sign if you really wanted equal sign in your identifier. Anyways, if it is an equals, we want to write to an instance variable, right? We want to write to a local instance variable, like a property or attribute of that object. So we call the object and we say write to the instance, and we pass it the method symbol, and the arguments. If we go look at write to instance, we go and we strip the equals off of it, and we make a symbol, instance name. We use the @ sign, and that lets us reference the symbol. So if we're actually trying to access v.c here, which we're not, it would be we'd access at c, right? So that's really what we're trying to make. We don't want at, where did I go? Okay, we don't want at v equals or anything like that. We don't want anything silly like that. So we strip the name, we make the new symbol, and then we can call instance variable set. Instance variable set comes from object, capital O object. And I assume most of your classes inherit from capital O object, and thus they have this method available to them. So using the current context, this is really like a self.instance variable set. It'll set that instance to the first arg. So I'll just set it to the first arg. Read from instance is the other alternative, where we just need the name of the symbol and we just convert it into an instance name. And then if it's not defined, then we set it by default. Otherwise, we return it. I know I'm not being very Ruby-y there, but whatever, nonetheless. So there we go. What this allows us to do is it allows us to set things as we please. And it's really like it's running attr accessor or write accessor. It's like it's running those for you on the fly. So it's like you're being really lazy and you didn't write down what your attributes are supposed to be, and you're just making them up as you go along. Should you write code this way? Well, probably not if you're working with other people, but it's definitely fun. All right. So here we got v.c. So that should assign x to c, both the instance variable, and it should make two methods for us, or act like two methods for us. It should have a c method and a c equals method. Then we're going to go v.a, v.b, v.c, vinspect. And vinspect will call a method for us that will just return the string. So I'm going to run this. Let's see. v.a, undefined. v.b, undefined. Notice it's not nil or anything like that. It's undefined. v.c is x because that's what we set it to. And then let's look at the object itself. So it's a Viva object. Its default is undefined. Its C is an X. Its A is an undefined. Its B is undefined. So on the fly, we were basically making up instance variables. Probably something you shouldn't be doing, but nonetheless something you can do, and no one can stop you because you have the power to do so. I like it. All right. So that was a little bit complicated. So I kind of want to see if there's any questions. No, we're good.
So just to break in while you break, Abram, I think the base of everything now in Ruby is simple object. That changed 2. I'm going to say 3, maybe it was 2.4. I can't remember. And so, I mean, the methods you were talking about, they might still be an object. They might have moved them to, they split some of them up because object has a few more things than simple object, but they needed something real plain vanilla at the base of the root tree.
Yeah. So, yeah, I was seeing that in the documentation. It wasn't clear to me where object was fitting in, but so you're saying most thing is simple object, and then itself.
Yeah, so near the standard is if you don't specify an inheritance, you actually inherit from object. Okay, but
so
object
you can go
itself
simple object
inherits from simple object, and simple object has some of the methods removed to provide something that was lighter. For there were certain instances where the things that simple object define or that object defined, they didn't actually want to be in the object. So it's a little bit convoluted, and it follows the Smalltalk principle. Everything is a class. So even if you don't say it inherits from something, it always inherits, and that is by definition object.
Okay. So moral of the story is simple object, top of the tree, but mostly everything's still an object unless it's not. Okay. So that was the first step to auto-vivification, auto-livening, auto-enlivening things. Perl's real value was the fact that you could access chains of objects and it would make them along the way as you went. So given $A, which is a scalar reference, equals to an object, you could go $A, go to key B, go to key C. It would cause $A to be equivalent to a hash that had B that had a hash ref here. So it wouldn't make C. Really what you were asking was, does C exist in B? A little bit weird. I don't really like those semantics that much, but I'll show you some code in Perl that would do it. So here we make a object, and then we go and check, does it have a C? We're going to check to see if A before what it is. This is just make a string. This is like a JSON dump almost. And then we're going to set C. We're going to dump it after, and I'm going to show you the collection of both. So I'm going to run this. Notice how I've run 3 different programming languages in the same presentation. And we can see that before, B has a hashref, and then after, B's hashref has C set in it. So it's very powerful, but what it requires is that B be created along the way, auto-vivified, auto-created, right? Because if we don't create the middle ones, we're going to basically do in like null pointer referencing and all that dereferencing, and that's not great. So let us take a look at this kind of behavior, maybe not exactly the same, but this kind of behavior with JavaScript. All right. So here's auto-vivify Perl style with JavaScript. We've made ourselves a get handler, and it's got its target, its prop, its receiver. We check to see if the property is not in the target. If the property is not in the target, what do? We make a proxy, which is kind of silly, but we make a proxy of a new object with this handler, which is kind of cool. It's recursively calling itself, but really all it's saying is, if you access that property and it doesn't exist, make it exist as one of these proxy things that has this handler. Kind of neat. Otherwise, just return it. It's just going to return it. Okay. So here we've got our object. Here we've got our new proxy, and it's got the Vivify handler. We'll set durian to be fruit, and then we'll print that, and we'll print salad. Then we'll print object.salad to see what happened to the original object. Then we'll just console log the object just for the sake of it. And then we'll go object.salad.what, and we'll see what happened to it. And then we'll go to the proxy object instead of dot, and we'll say salad.what, and we'll go see what that does to it. And then we'll go po.salad.what.huh.za. This is kind of like the foo bar of what, you start with what, za. I don't know what comes after za. I'm definitely looking for suggestions. Then we'll print out both of them. And then we'll check to see if dessert is in there too. And I think we should actually print out po again if we check if dessert is in there. All right, let's run this. Okay, the code ran. So let's look at this first line here. Maybe I'll just split it like this. So here's the first line that we're running. And what's the first line printed? What is it? It's durian. Okay, next line, .salad. .salad is an object. That's interesting. What about obj.salad? It's an object too. Okay. What about object itself? Object itself is a fruit durian and a salad object. And now I'm going to go object.salad.what. What do you think that's going to be? So we know that salad is there, and we know that what is not defined inside of salad. So we're going to get an empty object. What? Did I mess something up? I'm confused, but whatever. Oh, I know why I'm not. Does anyone see the problem? What do you think .salad is? Do you think it's a base object, or perhaps it's a proxy with the make Vivify handler? Yeah, it's kind of weird, right? Okay, so let's keep working our way down. So let's look at post-salad.what. Okay, cool. And then we'll print out the object again. I think that's this one. And then we'll look at .za, and we see that it goes deep, and this object's not allowing us to inspect it. It's just giving us a string. That's fine. And then I don't know where the true false came from. I'm getting confused. Oh, there it is. So salad in Po, true. Dessert in Po, false. We don't see dessert in there at all. And we print out Po again just to make sure that dessert's not there. And we see that dessert's not there. So we're good. Okay. And then this is just this is the result of console logs. So this was unintentional. Okay. So what happened? Essentially, once we got into the first one, proxies were set inside of this object. And so it was just proxies all the way down. That's pretty cool. But it also meant that I could do long things like this and they would be auto-vivified, Perl style. That's kind of neat. Now, this is slightly confusing, so there might be questions. Yeah, that's a good response. Okay. Now, I'll tell you what, it was a bit of a challenge getting that to work in Ruby, definitely. Okay. So actually, I'm joking. It wasn't. In Ruby, it was super easy.
Your screen, Abram.
Thank you. Right. In Ruby, I just copy and pasted Viva and changed its name to AutoViva, and I removed its default parameter. And instead of a default parameter, when it creates things, it just creates itself as that child member. It's that child instance variable. And it's exactly the same code as the last time. So we have a write to instance method that calls instance variable set. We got an instance variable set there, instance variable get. If you don't like this stuff, you can always replace it by actually defining the attribute, which is just code. You can just do it. Doesn't really matter. Nonetheless, our method missing is very simple. So we make a v AutoViva new, and we can assign X to C, and then I can ask the question v A, B, C, D. And then I can go A, B, C, D, E equals listgov violation, because this whole thing is a gross violation of listgov substitution principle, as well as the law of Demeter. So many dots, bad style. And then to prove to you that not all AutoVivas are the same, that each instance is unique on its own, I'll make a new AutoViva, and we'll just set one value in there, and then we'll inspect it. The first one we inspect will be our new one that has only one value. And then the last one will be this one. And I'll just run that. And let's take a look at what we have. So the first one is an AutoViva with an A instance. The next one has it's got an A, got a C. It's got a B, that's deeper, and a C. And then inside of that, it's got a D. And then inside of that, it's got an E. Isn't that neat? So it just made all those objects automatically for you because you abused method missing. Pretty cool, right? And this one wasn't hard at all. It was just copy and paste the previous one and just like change one line and change its name. Pretty fun. So you might think, that's just fooling around. It makes sense. I can do it if I want, but why would I really care that much? Well, one neat thing that you might want to do would be multi-methods. Multi-methods are methods that inspect the arguments of a method and then pattern match and delegate based upon them. So it essentially means you can make methods that are matching on types, things like that. It's kind of like overloading, except it typically requires runtime inspection of the arguments. Multi-dispatch is another way to say multi-method, and the terms are pretty interchangeable. There's a lot of libraries for both languages as well as documentation. In statically typed languages, you probably would use the visitor pattern, where you keep visiting back and forth on your arguments using the dot operator to do the inspection for you in a very complicated kind of way, but it does work. Nonetheless, multi-methods are neat because reasons why you'd use multi-methods would be like, maybe you've got a shape or geometry library, and you want, you've got a circle class, and you've got intersect, or intersect question mark. The query, does it intersect another shape? So if you didn't really know a lot about the other shape, probably what you'd do is you'd use essentially rectangle, rectangle intersection. Do their bounding boxes intersect? But we know that we can tell if two circles intersect by how far away, what the distance is between their radii is, right? If their distance is far enough such that it's equal to the sum of their radius or greater, then they're not intersecting, right? Well, I guess we can argue about that, whether or not they're intersecting at one point or not. But anyways, the point is that we've got math that's specific to, say, circle, circle intersection, and we can have math that's specific to circle, rectangle intersection, or circle, triangle intersection. And we could write all these special codes, and we could use them with multi-methods, because we could say, here's a method for intersect circle square. Here's a method for intersect circle circle. And multi-methods would allow us to inspect the fact that our argument, not just our object that we're delegating from, our argument is, say, a square or a circle. And so let's try to do multi-methods just by hand, kind of wimpy version of it, but one that you can do. And we can do it with proxy, and we can do it with missing method. Okay. Let me just check very briefly. All right, so we're good. Okay. So in JavaScript, we're going to start with a class. This class is example, and I'm going to use the $sign because I can, and I'm glad I can use it. And what the $sign is going to mean is it's basically the type of my parameters. So I'm going to have the A method, which is a meaningless method name. And this one takes in a number, and it returns X plus Y. This one, it takes in a string and a number, and it does a really complicated repeating of the string. This is a very complicated way to repeat that string n times. So if I give it X and I say 7, it should give me 7 X's. If I give it JavaScript and 10, it'll say JavaScript 10 times. Now, I'm going to intercept the get calls, and I'm going to, when I get that call, I'm going to see if I can actually, if I can handle that one. So you'll notice how I don't have an A method in example. There's no A method here, because really what we want is code that inspects the arguments of A and then delegates to the appropriate method to call. So really, I just want to call, like the code that I want to call is, where is it? Here it is. I just want to call A12 or AX5, right? I just want to call those things. I don't want to call a dollar whatever. No, I just want to call the simple method itself. So let's look at the handler that does the get. It converts our prop to a string. It checks to see if the target has that thing. If it does, calls reflection on it, and it says, go and get the target property using that receiver and return that. Otherwise, what it's going to do is it's going to make it. So if the property was A, right, it's going to assign target A to be make simple multi-method method, right? And then it's just going to reflect on and call it again. So what does this make simple multi-method do? Well, this is a function, and it returns another function because it's JavaScript, and that's what they do all the time in JavaScript. They love returning functions, especially when they have, you know, things like class, which would work perfectly fine. But whatever, this is my code. I shouldn't be complaining about it so heavily. We're going to return a function, and it's poorly indented. That was gross. And this function is going to make a method name. And this method name is going to be your method name plus a $sign plus the type of all your arguments joined together with more $signs. So this had better be whatever type of returns. So we're not going to do any fancy stuff here. No inspection to see if we got something that can handle it based on its superclass. It is what it is. We're going to delegate based on type. Okay. Then we check to see if that method actually is defined. Did we have an a number or an a string or an a string number? And then if we do, well, we just call it and we just pass in the arguments and we're all good to go. Otherwise, we throw a string. We're just like, I don't know, this is dumb. Okay, that's cool. So let's get it initialized. We got to use a proxy. We wrap our example object. We wrap it with our handler. We make that object. We go pe.a with 1 and 2. And so that'll be number. So it'll go x plus y. So it should return 3. And this is pe string number. So that will be string number. So that will be, 5 x's? Yeah, I think so. And then we'll call a method that I haven't defined yet, which is just string, and we'll see what happens there. I'll run it, and it ran, and we can see that it's a 3, it's 5 x's, and a string is not defined. Okay, that's pretty cool. So now we have a basic multi-method thing. If this was geometry, I could have intersect circle, intersect circle square, intersect square circle, that kind of thing. All right, I'm just going to quickly check. Oh, no, we're good. Okay, share my screen again. Okay, so that's multi-methods. In Ruby, well, actually, we're not done JavaScript. We don't actually need proxy to do it. Because we have prototypes, we can just make the simple multi-methods ahead of time if we want. So what we can do is we can say that I know that A is a multi-method, so I can just make the code ahead of time and have A delegate to anything that matches it. So using the same code I showed you from last time with the same bad indentation, using that same code from last time, we can essentially check to see if a method is already defined or huck an exception because it's not. And now we can share this to all examples. So this is how we'd set the method A for all examples. So A is now finally an actual method that's being called. We can get our example. We can go e.a and go check it out, run it, and we can see it runs just the same, but no funny proxy stuff, and our creation doesn't need to be there. So maybe we don't always need proxy, but things that are useful would also be things like reflect, your arguments, all that kind of fun stuff. Nonetheless, you can make multi-methods with or without proxy, with or without reflect, those kind of fun stuff. In Ruby, it's pretty easy too. Just going to check. We're good. Okay. Let's talk about multi-methods in Ruby's. For Ruby, we're going to make a utility method that inspects an object and suggests a method to call instead. So we're going to have a method called resolve simple multi-method. It takes in an object as arguments, the method, and the arguments to that method. So we're going to turn that method into a string. We're going to string add it with __. You could use any Unicode character you want, but __ is really easy to type. And then I map all the arguments to their class, and then I ask for the class's string name. We join those with underscores, and then we convert it finally to a symbol. Then we engage in reflection. We ask the object for its list of methods, and if that method includes this method. If it does, just return the method. Otherwise, freak out and raise an exception saying that method's not found. So here's our Ruby multi-method example. We've got our A integer, our A string integer. Notice how it's not number. We're in Ruby now. We actually can have, different kinds of numbers. That's cool. And we got method missing. Method missing takes the method name, method arguments, the block. What it does is it resolves the simple multi-method. It throws itself in there. It It gives the method name, the method arguments, it gets the name of the new method, and then it sends itself a message, which is kind of funny. This is definitely meta. This is self-reflexive right there. It sends the new method name to itself with the method argument and the block if necessary, and if it returns anything, it'll return something there. And our driver code, we make a new one of these. We run it on 1 and 2, and we run it on times 7. And just to show you I can do it live, I'll change it to 16 and it'll make a lot more X's. Okay, so that was pretty similar other than some fooling around, turning things to symbols, turning things to strings. It's very similar to the JavaScript code. I think it's a lot simpler. It looks nice. Ruby way definitely is pretty. And we can also try it out with something that's not quite defined. So we'll try it out with 2 strings, and we get the runtime error string not found. I can also pass itself in there, and it'll say string MME example not found. That's cool. It'll just look for an appropriate method. I guess the issue is you probably want to make it smarter such that it looks up the inheritance hierarchy such that it gets there. But, you know, we can always extend it anytime. So we could add 3 integers anytime. So integer, integer, integer. And then we can try that out. Of course, you could just use a multi-dispatch or multi-method gem from Ruby. There's a lot of pattern matching gems out there. But it's just good to understand how they actually, you know, kind of work together. So I want to see if there's any questions about this before I round out the end. No, still good. Okay. Metaprogramming. It's confusing. If you don't know that someone's metaprogramming on you, you'll be searching for code and you can't find its definition. It requires people to reverse engineer code, and they got to understand what's going on. You can't necessarily grep for function definitions with a lot of metaprogramming, especially the stuff I showed you. And to many people, it's surprising, which means it'll take them time to figure it out. To analyze it, you need a running system to test the semantics on. You kind of lose out with static analysis. But a lot of dynamic languages are that way. Lisp, Perl, all that kind of stuff, you can't actually parse common Lisp without common Lisp. You kind of need to be able to run and execute common Lisp to actually parse common Lisp. Perl's the same way. They can change how they get read at runtime, which is really weird. But it's kind of annoying. Sometimes you're going to have to use a debugger or debugger tools to figure out what's being called. In JavaScript, you can always call console.trace. In Ruby, you can always call the .backtrace on an exception. So that's always handy. But frankly, you're already in the dynamic zone. You've already gotten aboard the dynamically typed programming language train. You probably already know the dangers. And you've already heard words like, oh, shotgun surgery and stuff like that, really violent terminology that deals with the fact that you have immense power in these languages. You can do whatever you want. And it's more of a communication issue with other people that's really at stake here. So just watch out when you're doing that metaprogramming. So I'll conclude. Reflect and Proxy for JavaScript. They're your buddies for your metaprogramming in JavaScript. Also, understanding prototypes in JavaScript will help you out immensely. Method missing and object are your buddies for metaprogramming in Ruby. They got lots of useful stuff. The reflection and message passing for all the, you can rely on reflection and message passing to actually implement a lot of these constructs. But if you do, just watch out because you might confuse people or anyone reading your code. That said, it is really powerful and it can lead to really powerful things like the ability to dependency inject or mock tests and things like that. Metaprogramming is definitely something that's quite fun and doesn't necessarily require the actual generation of code, and it can just work in that system. It's really quite beautiful, the actual power that you have. Okay, so that's about it. I'm going to switch screens again. Okay, so thank you for your time. I hope you enjoyed that, and I hope you got questions.